How we doing, algebra? Welcome to this video that's going to give us an intro on a lot of different things related to functions. And we'll start simple. What is a function? A function is a rule that maps an output to an input to an output. So you kind of think of it like a machine, like a little vending machine. You put something in, you get something out. Now the way it works basically is we put in an x generally, and we usually get out a y. What we're going to find also is that sometimes we have a different x mapping to the same y, and that's okay. If you think about a vending machine, maybe there's multiple pieces, multiple columns of blue Doritos, because blue Doritos are the best Doritos. What we can't have, however, is if I put in my red X there and I want to get out the red Doritos, I can't all of a sudden have that same X get out for me the same blue Doritos. Alright, so this is no good. No good. Alright, that's important to remember. We'll talk more about it later. So let's take a look at an example of a function that's not just made up. Let's look at this one for a neighborhood child, and it gives an output as the month he or she was born in. So Max was born in January, Evan was born in April, Zeke was born in May, Rosie February, and Nico in May. First thing I would ask is, can we consider this a function rule? Can we consider this a function rule? I think yes. Because it's following a strict rule where an input maps to one output. Alright, there's never going to be more than one output there. We would never say that Max was born in both January and February. Evan was born in both April and May. It doesn't make any sense. Even someone like Rosie, if we say that she was born on February 29th, that leap day, we would not say that Rosie was born in both February and May. So it maps exactly one input to one output. I think that makes it a function. Alright, and what is the output when the input is Rosie? Well, we just said that. It would be February. And find all the inputs that give an output of May. Why does this not violate the definition of a function? Well, let's see. We have Zeke being born in May, and we also have Nico being born in May. Is it okay for two people to be born in the same month? Absolutely. These are still mapping one input to one output. It's okay that the output repeats. I'll write that. Output repeats. That's okay. Alright? And last thing I would just say on this slide is that this is just one of the forms that a function will come in. When you see a table like that, that is one of the three main forms that we'll see a function come in. Table is one of the three main forms for a function. Alright? Another form might be a graph. Alright, so we had the table on the first one. Let's check out the graph. We'll answer a couple of these questions. How far off does she start away from school? Well, she starts off right here. That's our start. We always read left to right. So it looks like she starts, I might say 21, but I want you guys to answer the question here and fix my mistake. If it's not 21, what is it really supposed to equal there? Okay, time is going to move along here for Charlene, so after 4 minutes, well, here's 4 minutes, I can go up, see that it's right there, and I can read it over here, and I'm going to say that that's 14. Alright, so what's her distance after 4 minutes? Well, she's got 14 blocks to go. How long did it take her to get to school once she got off the train? Where did she get on the train? Got to read the question correctly. Once she got on the train, well, it says she was waiting right here, looking for a subway pass, and then she walks to the train station, and then here she goes, she gets on. That's at minute 11, and after minute 15 she's going to get there, so we're going to go with 4 minutes. And we'll do more practice like this. It's just an introduction. This is one way to work with a graph of a function. Alright, remember, a graph is one of the three main forms of a function. The other type we might see is pretty simple. It's just the equation. And you guys have all seen equations before. Most of the time our equations look something like y equals 3x plus 7. Well, we have this new thing called function notation, and rather than using y equals, we're just going to use things like f of x. It helps for a couple of reasons. One of the big ones is that we can write different functions differently, and then it's easier to talk about them at the same time. If I tell you this is f of x, 3x plus 7, then you know when I say g of x, it's definitely a different function, x minus 6 over 2. And all you're going to do here is you're going to take these numbers that are inside, that 2 or that negative 3, and you're going to plug them in one at a time into that x value. Plug it in one at a time into the x value. So I'm going to pause it and just plug those in for those 4. Alright, so there are those set up, and we would just follow our order of operations to get some answers here. 3 times 2 is 6, plus 7 is 13. 3 times negative 3 is negative 9, plus 7 would be negative 2. 0 minus 6 is negative 6, divided by 2 is negative 3. And you know what? I'm going to leave that one right there for you guys to answer. Alright, that's the idea of function notation with equations. And this last slide, going to finish up very quickly here, just doing a little bit of extra graph stuff. I want to just introduce some ideas to you guys. This is going to go very quickly, and we'll practice it more next week. We're going to be able to find things like relative maximums, relative minimums, absolute maximums, absolute minimums. We're going to be able to find x-intercepts. We're going to be able to find y-intercepts. We're going to be able to find places where our graph is increasing. We're going to be able to find places where our graph is decreasing. All right, all sorts of stuff like that. I'm just going to pause it and kind of go through that very, very quickly. Those 3 yellow dots would be examples of relative minimums. Those 3 dots would be examples of relative maximums. And what I will say is, since this one in the middle is the highest, that would be the absolute max. All right, that's relative and absolute maximums and minimums. Those 5 green circles would be my 5 x-intercepts. It's okay to have a lot of x-intercepts. We could say that that is crossing the x-axis at maybe negative 7, negative 5, negative 1, positive 3, and positive 5. And this one red circle would be my y-intercept happening at positive 3. And last one, let me just draw in a couple of places where we see some increasing. We'll use blue, increasing, 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 all 3 of those. And if we look at the last 3, decreasing, decreasing. That's a bad color. Let me switch decreasing to yellow. All right, so 3 places where it's increasing, 2 places where it's decreasing, and that's a little bit of extra graph stuff for you guys. So thank you so much for watching. Answer the questions, and I will see you in class.